Hello, welcome to my YouTube channel, back with another one. And in this episode, I'm going to be doing a simple exercise. And in this exercise, I'm going to be doing a simple program that is going to be working with a palindrome. So we can go online and check what is a palindrome just for us to get the feel of the basics of what is a palindrome. So a palindrome meaning. So a palindrome is a word, a number, a phrase that reads both ways, meaning that it's a number that can be read forward and also read backwards. So like the number 111 is a palindrome because when you read it backwards, it's also the same. 313, it's also a palindrome. So in this case, I want us to do a simple exercise where we're going to be creating an application that is going to be doing a 3 digits number and check if that number is a palindrome. So it means this application should only be able to work with numbers from 100 to the number 999. Though then it should be able to detect whether that is a palindrome or not. So let us get to it. Class instantiation. So in this case, I'm going to do a scanner sc new scanner system.in. And then I'm going to do an int. I'm going to do a number, the number that we're going to take in. Then I'm going to have to split the number to digit 1, which is the first digit. I'm going to have to split it digit number 2, second digit. And then I'll need to have a digit number 3, which is the third digit. And then I must have the reverse order of that number. That should be sufficient. So now, in this case, I'm going to prompt user input. So system.out.println, please enter a number between 100 and 999 to check if it's a palindrome or not. I want it to appear in the same line, so let me just remove the ln. Let's do that, and then okay, now it's sc.nextInt because we're going to be dealing with an integer. Okay, so in this case I need to split. So let me just quickly open Paint so that we have a graphical view of what I want to do. Okay, let's just so now we need to process the information or split. I'm going to split the number to digits. Okay, that should be fine. Let's just quickly check if Paint is open here. So okay, then when we get here, okay, so now here is the case and the theory behind it. So the theory behind it is I have a number which is 1, 3, 1. I want to split this to be a single digit. I want to split that to be a single digit and that to be a single digit so that I can be able to move the last digit. It will now become the first digit. The second digit will remain in the second position and the first digit should then now become the last digit. So that at the end of the day, I can compare if this one is equal to that one. So if this holds, then it means that it's a palindrome. So now think about it mathematically. In programming, an integer divided by an integer gives you an int. So if I have the number 100, if I divide this by 100, then it means I'm gonna get the number 1. So that should be this first digit, which is fine by me. If I have the number 200, if I divide it by 100, I shall get the number 2, which is the first digit, which is fine by me. If I have the number 213 and I divide this by 100, I should get the number 2, which is the first digit, which is fine by me. So what I'm trying to give you here is that in order for you to get the first digit, you will just have to divide by what? By 100. Now, in order for you to get the second digit, which is this one in the middle, what you can do is that you can take the number 131, you can then divide it by 10, it'll give you 13. And once it gives you a 13, if you do a modulus of that by 10, then this should be able to give you the number 3, which in this case is actually the second number, which is the second digit. So it means in order for you to get that, you need to first divide by 10, then get a modulus to get the remainder. So it means how many times does 10 go into 13? One time, what is the remainder? Is a 3. So even when this was 157, if you divide this by 10, then you'll get 15. Why? Because in programming, an integer divided by an integer should give you an integer. Everything after the comma should be cut out. So then this, you're going to get a 15. Then after when you got a 15, if you do a modulus of this by 10, how many times does 10 go into 15? One time, remainder is a what? Is a 5, which is actually the second digit. So we have already also sorted out the second digit, which is that one. So now, in order for us to find the third digit, let's take the number 131 again. If we just modulus this by 10, it will be sufficient to always give us the remainder of what is the side. How many times does 10 go into 130? 13 times, what is the remainder? The remainder is equivalent to a 1. If I say 157 modulus by 10, divide, I use the percentage sign, modulus by 10, then this should be able to give me a 7, which is the last digit. Why? Because how many times does 10 go into 157? It goes in 15 times. What is the remainder? Is a 7. So we have figured out a way on doing this. Then now we need to translate it and take it to a what? To a code. So now let's go back to our IDE. And then when we get back here to our IDE, after when you've taken that, we're then going to say digit 1 is then assigned to num. What did we say? We just divide by 100. That should be given as the first digit. So, okay, digit 2, that should be the number divided by 10 modulus by what? Modulus by 10. That should be able to give us a remainder. So the third one, it should be digit 3, and you just say num modulus by 10. That is what we were doing that other side. So this is a modulus by 10. So this should be able to give us the first digit, the second digit, and the third digit. Now we need to reverse the number. So how do you then reverse the number? We've already declared it as a reverse. So to reverse the number, you take the third digit, which is the last digit, digit number 3, you multiply it by 100. So when you're working with a 3-digit number, it's firstly in hundreds, in tenth, and also in ones. So you add digit number 2, multiply by the 10th, plus the third digit, which is digit number 1 in this case. We're just going to add digit number 1. So that should be able to give you the reverse. Why? Because when we're splitting it as digit 1, digit 2, digit 3. Now we are reversing it, starting with digit number 3, digit 2, digit 1. So now we now check if it's a palindrome or not. So how do you check if it's a palindrome or not? We're going to use an if statement. We're going to say if num is equivalent to the reverse, meaning that if the number is readable in reverse, then we're going to system out the number And then we write it there as num is a palindrome. There we go. Then here, if that doesn't hold, we're gonna have an else part. Remove the E. Then the else part, we're gonna say it's not a palindrome. So we say that the number, we show the number is not a palindrome. So there we go. Once you have that, that means that should be held. The only trick here is for you to split the number into digits, which I've explained on the side. Whenever we're working with the paint here, I've explained the theory that side. Whenever I was working with the paint, that's how you do it. And now, when you get to that level, it means that you should be able to understand that, okay, this is how you split a 3-digit number. So I'm going to leave it up to you to do a 4-digit number, 5-digit number, and all of so on and so forth. So now, in this case, maybe we're going to do a 5-digit number, the one which is big in one of the videos in the future whenever we're dealing with an exercise. But for now, let us deal with the 3-digit number. So now, let us make a last thing. Let us control this. The whole thing must be controlled, because we do not want a user to enter numbers which are beyond the range that we are looking for. So now, okay, immediately after the user has given us the number, we need to check. We're going to say if, a big if statement here. We're going to be saying that if num is greater than or equals to 100 and num is less than 1000, which is going to be 999. So now, if that's the case, then we're going to work inside here. We are allowed to do everything that we were doing here. Let's just tap this whole thing here. Tap this. Else, it must say that a wrong number has been entered. So now system.out.println, you have made an invalid input. Only 3-digit numbers allowed. There we go. So only 3-digit numbers will be allowed. That is going to be controlled by that if statement. And then now this should be sufficient for it to be able to work. So now let's try it out. Let us put in the number 99. Then it should say you have made an invalid import, only 3-digit numbers allowed. So it's only going to restrict the user to only check with 3-digit numbers. So now let's check the number 111. And as you can see, 111 is a palindrome. Why? Because 111, when you read it forward and when you read it backward, is still the same number. Let's try number 121. If we check, the number 121 is actually a palindrome. Why? Because it's read backwards. Let's try a number which is not a palindrome, like your 123. And when you see it's not a palindrome, because 123 is read as 123 going forward, but when you read it backwards, it's 321. It's not a palindrome. So let's check the last number. The last palindrome, 3-digit palindrome, is 999. So that is actually a palindrome, showing us that our application is actually doing what we expected it to do. So that is it from me for today and today's exercise, in order for us to exercise whatever information that we've been doing so far, which is to create an application that is going to determine if a 3-digit number is a palindrome or not. That is it from me for today. Please remember to like, share, and subscribe, and till the next upload. And that is it from me. Cheers.